Welcome to Homework Lib.
So in this question, we have the hydrogen molecule, and we know that for hydrogen molecule, you have two hydrogen atoms, and you have the equilibrium spacing of the two atoms be 0.074 nanometer. So the mass of the hydrogen atom is 1.67 times 10 to the negative 27 kilogram, and we want to calculate the wavelength of the photon emitted in the rotational transition from R equals 2 to L equals 1. So in order to solve this question, we want to think about the energy emitted in this case. The energy of the photon is equal to the energy difference between the L equals 2 and L equals 1 states. So the energy determines the wavelength of the photon. So the first thing we need to do is we need to find the reduced mass of the molecule. The reduced mass and reduced is, so the formula we have is m1 m2 over m1 plus m2, but here because the two atoms are the same, it's just half of the mass of hydrogen. And then from knowing the reduced mass, we are able to find the moment of inertia. I equals reduced mass times R naught squared. So this tells us the moment of inertia. And then, after we found this, we can go back to look for the photon energy. So photon energy is given by delta E equals hc over lambda. But then the energy of the state, EL, is equal to L times L plus 1 h squared over 2I. So this is the energy of state we have, but here we're looking for the change of energy of state. So when the state changes from L equals 2 to L equals 1, the change of energy delta E is equal to, when L equals 2, we have 6 times h squared over 2I. When L equals 1, we have 2 times h squared over 2I. So together, we have 2 times h squared over 2I. And from this, we can finally find the answer to our question. We are looking for the wavelength, and wavelength is equal to, look at this formula, wavelength is equal to hc over delta E, but then delta E is equal to hc, delta E is equal to h squared I. And then I, again, is equal to mr squared. So this is h over c times I equals reduced mass, which is half of mass of hydrogen, times r naught squared. So h equals 6 times 62 times 10 to the negative 34 joules per second. And c is speed of light, 3 times 10 to the 8 meter per second, times 1/2. Mass of hydrogen is 1.67 times 10 to the negative 27 kilogram, and finally times 0.074 nanometer times 10 to the 9 squared. So we can calculate this number, and this is 4.08 times 10 to the negative 5 meter, and if we put it in proper units, it's roughly 40 micrometer. So this wavelength is much shorter than that of visible light. We're not able to see this light.